Okay. In this unit, we're going to do the reverse process of taking a derivative, which is called an antiderivative. So previously we were given f of x and you were asked to find f prime of x, the derivative. So now what you're going to be asked to do is you're going to be given f prime of x and go the other direction and find f of x, or the original function that would give you that derivative. Now, we're gonna introduce the idea of a capital F also. So if I give you f of x and I ask you to find the derivative of that, that would be called f prime of x. So we've done this before. But now if I go the other direction, if I give you f prime of x, going back to that original function, which I'm going to call layer up, is called f of x. But if I go one more layer up, so if I give you f of x and I ask you to give me that function, we're going to call that capital F of x. So this would be the order. So let's say you are given little f of x is 2x. Can you find big f of x? So what we're trying to do is figure out what is the original function that would give you a derivative of 2x. And there's going to be lots of them. X squared, the derivative of that is 2x, so that will work. But what about x squared plus 1? The derivative of that would also be 2x. And really, I can put any number added or subtracted. I can do x squared minus 5. This would also still give me little f of x, or the derivative big F, as 2x as well. So when we talk about an antiderivative, there's a whole family of antiderivatives, and I'm going to call it x squared plus any constant c, where c is any number that could be positive or negative. And let's think about graphically why it makes sense. If you think about x squared just looks like this, right? It's a parabola. Now let's look at x squared plus 1. The only difference is this graph is moved up 1 unit, so this graph would look like this. Now, if you look at the graph, let's think about the slopes at the same x value. So at x equals 0, the slope is 0 in both of those graphs. At x equals 1, let's draw a tangent line and see what happens. There's my tangent line, there's my tangent line. So notice at the same x value, your slope of the tangent line is the same. So that's why all of these would yield the same derivative of 2x. So any vertical translation of the graph would not change its slope. Okay, a couple of vocabularies, ideas that we need to talk over. So when I ask you take the antiderivative, this is the symbol we're going to use. So that symbol means take the antiderivative of f of x with respect to dx, and then the answer to that problem will give me big F of x plus c. So this symbol right here is called your integral sign. So I would say the integral of f of x. The whole piece right here is called an indefinite integral. The f of x piece is called your integrand. The dx is your variable integration. And then the c that comes in our answer is your constant of integration. That should always be in your antiderivative answer for an indefinite integral. Okay, we're going to just take a look at a couple, and we're just going to kind of try it based on what we know about derivatives. So what would be the original function that would give you a derivative of x to the 4? So you should be thinking, okay, when we take the derivative, we reduce the power by 1. So the antiderivative should have a higher power of 1. So it's got to be x to the 5th. But if I just take this derivative is 5x to the 4th. Well, this doesn't lead to here. So how do I get rid of that 5? If I put that there, let's check our derivative. So if this is big F of x, little f of x, we can check it, is bring down the 5, reduce the power by 1. So that leads me back to my original function. So this would be my antiderivative. And remember, for our antiderivative, we always need that constant of integration. Okay, this is just one of our trig rules. So if I take the derivative of the sine, it'll lead me back to the cosine. And then this one, same idea as the first one, but again, we need to add 1 to the power instead of reducing by 1 to do the antiderivative. And notice, very similar to what we did here, notice you divide by the power. So I'm going to divide by the -2 here. And then we need that plus c.